Let's talk about vectors for the next several minutes. Vectors are one-dimensional arrays of numbers, and they are very useful for storing data. We're going to create vectors in a couple different ways. Let me stretch this a little bit so we have more room on the console. And I'm going to create a variable called initial size. And I'm going to make use of the built-in function c parentheses, and we're going to enter numbers here and separate these numbers by commas: 1, 3, 5, 7, 9, and 11. So we have stored in the variable initial size a vector that contains these entries. If I like to see these entries, I can retype the name of that variable, and I can type a few initial characters and use the tab keystroke. Okay, if I use the tab in the keyboard, if I use a tab, then I will get an option for the variables on memory that can be completed that contain these characters. So I choose the first one, which is the one we just defined, and then this displays the numbers we have stored in that variable. So let's now define another variable called final size, and I define this as initial size plus 1. This will be doing an operation on every entry of this array of numbers of this vector. Is going to be adding 1. Okay, and I'm going to use the upward arrow on the keyboard. With the arrow pointing upward, I can go back to commands on the console that I had previously typed, and after the semicolon I type the name of the variable that I just defined, and this gives me a display of the numbers. Okay, so this is doing an operation on every entry of this vector. I can add, subtract, multiply, divide. I can take the square root. Let's say new size is sqrt square root of initial size. Okay, and this is, and again, another operation that's acting on every entry of this vector. Another thing I can do is raise to a power. I can take those values 1, 3, 5, 7, 9, and 11 and square each of those values. I would do that by taking the variable that stores the vector and using the power to the 2, the second power. There are other ways of creating vectors. If there are too many entries, if the vectors are large, then we can make use of the command seq, or sequence, and this command only requires if we specify the initial value, the final value, and the step size. So we can, to have the numbers we had used in initial size, we can say start at 1 and at 11, and you can see how the increments here are, we're adding 2. 1 plus 2 is 3, 3 plus 2 is 5, and so on. So we can say by equals 2. This specifies the step. Okay. We can also use the sequence command by saying start at this number, end at this number, and specify how many entries we want. Say, for example, start at 1, end at 3, and have a length of 6. This gives numbers 1, 1.4, 1.8, 2.2. So there is 1, 2, excuse me, 1, 2, 3, 4, 5, 6 entries on this vector. Okay, we can create vectors also by using the column. If I type 1 column 8, this will take automatically steps of 1, starting at 1, ending at 8. I can also use the combine or concatenation built-in functions, say 1 column 8. We can also create vectors that have repeated values. For example, let's say we want to create a vector with ones. I say repeat 1 a number of times. Repeat 1 10 times. This would be a vector with 10 entries, each of them equal to 1. I can say repeat 7 5 times. We can also use the rep command with a vector of values and their associated lengths. So if we wanted to repeat, say for example, the number 3 and the number 4, okay, I type rep and first specify what are the values that are going to be repeated. I'm going to say 3, 4, and then I specify how they are repeated. Okay, so I say 2, 5. This will give the following output, in which number 3 here is repeated 2 times and number 4 is repeated 5 times. When we're dealing with vectors and we are constructing vectors, it's important also to know how to address or access some of the entries of these vectors. So let's say, for example, we create a vector that we call Q that starts at 1, ends at 11 in steps of 2, right? And we want to access, say, the fourth entry of this vector. So we type Q square brackets, and inside the square brackets we specify the index with the location of the entry we want to access. If we look at the entries of Q, 1, 3, 5, and 7, the number 7 is located on the fourth entry. I could define another vector, say V is a subset of the entries in Q. For example, entries 2, 3, 4, and 5. I would type square brackets and then 2 column 5. I could also define a vector in the following way: Q square brackets, and I can choose some of the entries, not consecutively, but some, say entry 1, 2, and 5 of vector Q. Right, so here's the original vector Q. The first entry is 1, the second entry is 3, we skip the fourth, and then the fifth entry, excuse me, this is the first, second, third, fourth, and then the fifth entry is the number 9. So that's exactly what this new vector W stores, 1, 3, and 9. Another application of accessing some of these entries is to make replacements. Remember, the vector Q contains, let me display this again, contains entries 1, 3, 5, 7, and 9. Let's say, for example, I'm interested in replacing the second entry. So I will access or address the second entry and then write equal to the new entry I want to store in there, say, for example, 20. If I do this and display the vector Q, you can see that the original Q had the number 3 on entry number 2, but now that 3 was replaced by the number 20. And this concludes our brief introduction to vectors in R.